Okay, welcome to Congruent, Complementary, or Supplementary. Now this video and this lesson will act as a reteach on some of the concepts that you really struggle with on our Unit 2 test. Okay, for example, look at this. This construction here, where you see these arcs that are crossing that almost look like X's, it creates this dotted line, and when you do this, when you perform this construction, you are actually bisecting, line AB. What does that mean? It means that we're cutting AB in half. And if you will recall, M is our midpoint. Well, what's important about our midpoint? It's telling us that when AB is cut in half, this left line segment, AM, is congruent to this right line segment, MB. Now there's another two types of relations here, but we're not going to cover them in this video just yet. Just understand that the midpoint cuts this into two congruent segments. Okay, here we have example 2. Now if I didn't mention it, my apologies. In that very last construction, that was creating a perpendicular bisector. And using this word bisector again, well, what is this? This is an angle, so it only makes sense that when you see this arc right here, and then these intersecting arcs right there, this is the construction of an angle bisector. Okay, and what is so key about an angle bisector? Well, it's telling us it's cutting the angle in half. Now you'll notice here we have this leftmost angle, and here we have this rightmost angle. And how do we say that we have two congruent angles? Well, let's go ahead and take in this orange, and this orange is from this line to here. So we can say this, we can say angle C, now it looks like an O to me, COA is congruent to, and then let's go ahead and use this nice purple here. Here's the other part of this, to angle BOC. So guys, whenever you cut something in half, we're saying like, okay, this half must be congruent to this other half. Alright, let's check out our next set of geometric statements. Okay, for example 3, we have two lines intersecting at point W. Now point W is not remarkable except for it's just the point of intersection. Okay, it's just our point of intersection. Alright, and that's an I right there. Now, what do we know when we have two lines cross? Well, we know that we actually create vertical angles. We know that our opposite angles are congruent to each other. So we could say this, we could say that angle, let's follow it like this, angle SWU is congruent to angle, and of course that opposite angle, VWT. Now that's not the only set of congruent angles there. There's also this one right here in the purple, and that is opposite of that. So we could also say angle SWV is congruent to angle UWT. Now, we're talking about congruent things, we're talking about supplementary things, we're talking about complementary things. Well, these are also unique in that they also have our specific type of supplementary angles. Notice this is a straight line. And in fact, what I have in the purple is adjacent to what I have in the orange. So what are we also saying here? Okay, let's take what I have in the orange. We have this angle SWU plus, and here what I have in the purple, this angle right here, angle UWT. And guess what, guys? Whenever they are on a straight line, we know that they are in fact supplementary, and they must add up to 180 degrees. Now that's not the only pair of supplementary angles there. We could also see, for example, right here, we have this purple and we have that orange, and those two could add up to 180. In fact, we could say angle SWV plus angle VWT is equal to 180 as well. Now I would leave you to show this yourself, but there's actually two more sets of supplementary angles. Alright, let's move on to our fourth example. Oh, and before we move on, just real quick, what if you ever see something like this where it's two triangles? I like to call this the bow tie problem. Remember guys, even if it's two triangles, as long as these two lines are intersecting, they are creating those vertical angles. What about an isosceles triangle? It looks different from everything that we've seen so far, but don't forget, isosceles triangles also have some congruent angles. And I want you to think about it. Can you remember where our isosceles triangles have congruent angles? Well, if you said that they have congruent base angles, you would be 100% correct. And guys, I want y'all to realize, hey, this tick mark and that tick mark indicates that this side BE and this side BG, well, we know that BE must be congruent to BG. Okay, so there's one statement of congruency, but what we're really focusing on here is going to be these base angles. In fact, let's write that. These base angles. And I know that my base angles must be congruent. Okay, so I can say angle BEG is congruent to angle BGE. Okay, perfect. So guys, isosceles triangles are cool because they actually have two sets of congruent sides. They have the congruent sides and the congruent angles. Alright, we have one final example. Let's go check it out. Okay guys, and here's our last example for this video. We're going to talk about this little bitty box. And before I say what this little bitty box is, I want you to recall whenever we see that box, we could also say this. AB is something to, BD. What does that upside down T symbol mean? Well, if you will recall, that means that they are perpendicular. And guys, what do we know about perpendicular angles? Well, they're 90 degrees. So what could we say here? We could actually say, I'll use this nice purple here, that this part right here, angle ABC, plus, let's go back to this nice orange, angle CBD is equal to 90 degrees. Alright guys, I hope that these simple constructions helped you out. Let's move on to the practice, and I'll see y'all in our next video.